Hello, everyone. Welcome to tonight's session of our Where's Waldo webinar. Tonight's webinar is going to be entitled Getting Your Ideas into Patients Through Collaborations with Industry. We're very excited to have Dr. Fred Lee with us here to present this topic. Just a little bit of background for those of you who have not attended these webinars in the past. This is part of a series that is supported by a grant from the AUR Arnie Venture Grant funding. And it really is intended to help mid-career faculty to stand out from the crowd and to help with those career pivots that mid-career faculty are often facing. The purpose of the grant was to develop and implement a curriculum for career development targeting that mid-career faculty group. And it's composed of a number of different components. One is the webinar series that you're all attending now, and this is open to all AUR members. We're also going to be providing a reading list of high value materials that we have found useful for career and personal development, which will help you along your journey. We are also providing curated YouTube videos on productivity topics, which will be housed along with the remainder of the grant material. And then I invite you all to apply for the small group development group, which involves a number of different things, including a Coursera coursework that will be done together by all of these small group members. There will be research and writing mentorship available. We'll do some CV analysis, look at personal gaps and finding those and how to fill in those gaps with the peer group activity. The current application process is actually open, and we will be putting the application link into the chat shortly. So I encourage you all to apply for this small group. I think it's going to be very high yield. And without further ado, I'm going to turn this over to Dr. Robbins to introduce our speaker.
Great, thank you. I am so excited to introduce my colleague and my mentor, Dr. Fred Lee, to you all. I could talk for about 3 hours on all of the wonderful things that he's done, but I won't. Some of you may have heard Dr. Lee speak about like small waves and the ripple effect that those small waves have on the future. And Dr. Lee made one of those small waves early in my career, and the ripple has really landed me where I am today. So one plug I'll add is for you to find people like Dr. Lee in your life who make a small ripple and have huge impacts on your careers as you move forward. Dr. Lee is a professor of radiology and biomedical engineering and urology at the University of Wisconsin. All of his amazing innovations, inventions, and ideas have really transformed how we care for tumors in patients. And his ideas have led to the foundation of 2 companies, NeuWave and Elucent Medical, with a 3rd in progress. So without further ado, I will turn this over to Dr. Lee to tell us how we can get our ideas into patients.
Well, thank you for that very kind introduction, Jess. Can you guys see my screen here? Oh, there we go. Can you see my screen? Great. Tara and Panit and Jess, thank you very much for the wonderful introduction. And to those that are spending your precious evening here, thank you for your attendance. Today, I'm going to talk a little bit about how your great ideas can get into patients, primarily through collaborations with industry. And I think that is probably the prime way that this can happen, at least in the United States. And I'll take you a little bit on a journey and tell you a little bit of history about how that's happened in the US, and then I'll show you a little bit about what we've done with some of our companies. So here are my disclosures in several different areas of medical devices primarily. So our learning objectives today are, we're going to talk a little bit about the history of technology transfer and how things go from an academic idea to patients at the bedside. We're going to talk about physician inventors. Is this a good thing, a bad thing, or doesn't really make any difference? We're going to talk briefly about problems that are ripe for medical device innovation in radiology and in other spaces. And for those of you that have an idea, I'm going to give you some ideas about how to get started. And then we're going to talk lastly, just a little bit about how to bring your idea to market. And I have done this a number of times. I'm just going to tell you how I've done it. And I don't know if that applies to your particular situation, but at least I'll tell you that what my experience has been. Okay, So let's start by talking a little bit about invention in the medical space. And after World War II, the large multinational companies based in the US like RCA, GE, Bell Labs, Westinghouse, they all had these incredible in-house laboratories. RCA Labs is one of them that I'm very interested in. They invented things like the color TV, LCD, VCRs, EM, all kinds of crazy things in their in-house lab. And in fact, many of you, especially those that are based on the East Coast, might know Ruben Mesrick, who is the chair of radiology at the University of Maryland. And he was involved in the RCA labs with the invention of the color TV. So it's a little bit of a link to our world. But what happened is that in the 1950s, the 1980s, a wave of, I'll say mostly Ivy League educated MBAs came into those companies, and they saw the labs as an expense line only. And there was no revenue that was associated with these labs. And so they started to cut the budgets of these labs and eventually shuttered them, which was a huge problem for innovation within large companies. So then what happened is out in Silicon Valley, this large medical device culture filled the void that was left behind by the closing of these laboratories, and physicians started to get involved with some of the medical device companies that were springing up. And of course, once that happened, the venture capitalists sniffed a profit in the making, and they started investing in some of these companies. Eventually, the large companies who had destroyed their own internal laboratories realized that they needed innovative new devices to keep their stock prices up. And so they started buying the best of these venture capital funded companies. So that's kind of what was happening in the 1950s and 1980s. But interestingly, universities and academic centers, they were not a big source of invention prior to the 1980s. And I'll explain that in a minute. Now, something happened in the 1970s and 1980s, and I was a kid in Ann Arbor, Michigan, when this happened, and that is that the Japanese auto companies started to innovate like crazy, and they brought over these incredible vehicles. And I remember the Honda Civic when it first came to the United States because one of my best friend's family bought one. And we drove this beat up old Chevy van, you know, that had holes in the bottom and rust and all this stuff. And when this Honda Civic showed up, I took a ride in it and thought to myself, this is the most technologically advanced thing I've ever seen in my entire life. And people were aghast at how advanced these cars were. And then, of course, the market followed. And you all know what happened is that the Japanese cars started taking increasing market share from the US car manufacturing companies. And that led to the decline of Detroit and Flint, Michigan, and some of the great cities of the Industrial Revolution in the United States. Well, the United States didn't sit still when this was happening. And these two characters at the bottom right, which is Birch Bayh and Bob Dole, who some of you know because he ran for president, Bayh was a Democrat and Dole was a Republican. And they actually got together in something that could never happen today. These two guys got together and decided they wanted to do something about the competitiveness of the US auto industry. And so they sponsored the Buy Dole Act of 1980. And this was largely in response to the auto industry. And what it said is that if you're at a university or you're at a small company or not for profit, you can take your inventions and you can commercialize them yourself. Before the Buy Dole Act, this didn't happen. All the patents and things that happened at the universities were not commercialized. There was no urgency for commercialization. And so nothing happened with all these inventions at universities until the Buy Dole Act happened. And once this happened, there was a huge wellspring of response that happened after the Buy Dole Act passed. And this is just some of the data that shows what happened, especially at university centers. I mean, thousands of companies were formed. I was really interested that universities formed 2 startups per day, and I think it's more than that now. And what happened is that these biotechnology clusters started to happen around major universities. You all know about Silicon Valley, but in North Carolina, there's a biotechnology cluster around Duke and UNC. Here at UW, we have a little bit of a biotech cluster going on ourselves, mostly catalyzed by this act. The licensing activity from this act added huge amounts to the economy, serving huge amounts of jobs. And now, if you're a life science company in the US, you pretty much have to have a strong relationship with the university. So this is one of those rare bipartisan things that ended up being incredible for the United States in general. Now, this is where Jess and I work. We're at the University of Wisconsin in Madison, which is the number 6 research spending institution in the US. Our research budget is over $1 billion. We've had 19 Nobel Prize winners from our faculty, staff, and students. And you can see our university is on a isthmus in between 2 large lakes. This is originally, Madison, Wisconsin was originally a Native American settlement between 2 lakes. And we've had all kinds of medical discoveries at UW. Most of these were catalyzed by the Buy Dole Act. You can see in 1998, Jamie Thompson, who's pictured on the right, and who's actually lives in Jess's neighborhood. He's cultured embryonic stem cells in 1998. Interestingly enough, he was the only medical staff member at the University of Wisconsin. He wasn't even a faculty member, he was a scientist. He went from an assistant scientist to a full professor. He's the only one that this ever happened to at UW. They built a huge building for him. They named a big institute for him because of the culturing of embryonic stem cells. We invented digital subtraction angiography in our department. You've probably heard about the UW solution, which preserves transplant organs and 5FU, all these vitamins, all these crazy things were invented at UW, mostly catalyzed by the Buy Dole Act. Now, one of the things about Wisconsin that also helps push discoveries into patients is something called the Wisconsin idea, which is a idea that was from one of our early presidents around the turn of the century, 1905, where he felt that research that was performed at public universities, land-grant universities like ours, should be used for the benefit of the residents of the state. And so every year, our campus looks at all the spin-off companies and all the benefit to the state that came from the university research and the hundreds of spin-off companies and puts a report out. And it's something like, right now, I think it's something like $5 billion university spin-offs contribute to the economy of the state of Wisconsin, which is otherwise a small state economically. So the impact of these kind of discoveries on your hometown and your state can be really huge. Okay, so people always say to me, yeah, that's fine. This is all big industry stuff, and there's engineers and labs and all the stuff that are inventing devices and ideas, and what about doctors? You know, I'm just an ordinary doctor, and I read scans and I perform procedures, and what do I know? Well, my answer to that is, if you don't invent things, who's going to? Because if you don't, there's going to be some engineer in a lab that has never seen an X-ray, never diagnosed a condition, never placed a needle into a patient. That's going to be who is going to invent the next generation of medical breakthroughs. Physicians are the ones that should be inventing medical devices, medical procedures, and the technology that we use every day. And you can see I have a big list of inventions on the left here that physicians have been the primary inventors of, and it's a very long list. In our world, PAX was invented by a physician, as well as everything else you can see here that we use every day. Now, if you look at the picture on the right, this is a guy and is holding a couple of things. And I don't know if any of you recognize him, because he is probably the first and the foremost physician inventor in the United States. And he had a little bit of a rocky start, but it ended up incredibly well. And his name is Thomas Fogerty, and he invented the Fogerty Catheter. And his story is really interesting. He was a troubled youth. He grew up in Cincinnati, and he kept getting into scraps with people and was thinking that he was going to be a professional boxer, until he met a vascular surgeon at the University of Cincinnati who took him in and kind of mentored him. And by the time he was 14, he was a surgical scrub tech. Can you imagine that? I mean, in the 50s, anything was possible, of course, at hospitals, but a 14-year-old is your surgical scrub tech, and he was great at it. And so he watched all these vascular surgeries happening, and one of the things that he noticed was that the only way to get a clot out of an artery or a vein was through a big open surgery to open up the vessel and to pull the clot out by hand. And that, of course, was very damaging. And in the course of his becoming a medical student, and he was an avid fly fisherman, he put together the very simple invention of the Fogerty Catheter, which has gone on to save millions of lives and limbs. And so he made his original observations as a teenager and patented his invention when he was a medical student. And so it's that kind of catalyzed things. He went on to make many other inventions and become a venture capitalist. And he's one of the ones that's credited with starting the invention and entrepreneurship of physicians in Silicon Valley. So he's somebody we can look to learn lessons about the impact of doctor, physician, and entrepreneurs. The data is also really good, and I won't go through a lot of this other than that to say that 80% of the highest rated and the biggest selling medical instruments were discovered by physicians. And one of my friends, a very senior Ethicon Johnson & Johnson executive, told me that we pay particular attention to physician-invented devices. Because frankly, physicians, us, we know what our peers are going to like. We know what's going to be impactful when our friends use it. And so we are in the best position to decide what is going to be useful. So I think the jury's not out anymore. Doctors make the best inventions, and that's your responsibility. So what should I be working on? And people ask me this all the time. And my answer is anything that you're interested in, you should be working on. But I think there are several kind of areas that may be more fruitful to work on than others. And one of the ones that I'm fairly passionate about is jobs that are complex and take a lot of skill to do, and you have to be a super physician to do it. That's probably an area that needs innovation. And I'm particularly passionate about robotic knees because I'm getting a knee replacement in July, and I've been making the critical error of watching knee surgery on YouTube videos, which is really horrifying. But I've been watching all the new technology that's been in place for doing robotic knees, and it's incredible. This robot on the right, many of you know about it, the Mako Robot. It sells for over $1 million. And what it does is it aligns knees versus plan slightly better than manually. And this is 1.6 degrees difference. And yet that is worth $1 million robot. And every single medical center has this. So this makes knee surgery more reproducible, faster, and easier. And because of that, the value of this company is incalculable. So if you have an idea that makes something less invasive, more reproducible, fewer side effects, faster, you can see something better, that's probably something that you can innovate in. And in radiology specifically, if there's less radiation, if you have better images, more specificity, all those things are marketable. And then something that I think is really marketable, and we work a lot at in our practice, is there something that drives you crazy about your job? Are there a lot of clicks on the computer? Is the workflow really bad? That kind of thing. If you can make the user experience better, that is going to be marketable. If it drives you crazy, then there's a chance for innovation there, okay? And I love this. Don't underestimate the user experience. Apple Computer really understands this, and many other companies do not. And I want to give you these quotes because these are two CEOs that were poo-pooing the iPhone when it came out. And one CEO said, Apple's approach produced devices that inevitably sacrificed advanced features for aesthetics. And this is the former CEO of BlackBerry. And there's another CEO has a quote, you can get a Motorola Q for $99. Apple will have the most expensive phone by far in the marketplace. There's no chance that the iPhone is going to get any significant market share. No chance. Well, that's another former CEO. And what Apple did, they didn't invent anything incredible. They just made the user experience really great, and they took a huge market share. So if you have a way of making the user experience great, if you can make your friends happy by making workflow better, making their job easier, that is a marketable idea. Okay, so how do you start? The first thing is, and this, I want to be very, very clear about this, that your day job, if you're an academic or a private practice radiologist, this does not conflict with being an inventor and being an entrepreneur. Now, there will be conflict of interest rules and things that you have to follow, but this is not in conflict what your primary mission is. In fact, you are supposed to be inventing things. You're supposed to be driving the world, and being an entrepreneur is one way to do that. And it's an increasingly important way to do that. So I would just say, if you're interested in getting started in this area, just do something. I mean, just build something, make something, prototype something. Don't be paralyzed with this analysis paralysis about what is, and I'll explain to that in just a minute. You should ask people about what to work on and show them your inventions and stuff like that, but it's not a democracy. I mean, it in a way, it matters what other people think, but it also doesn't matter what other people think, because other people are usually wrong. And Henry Ford said this very nicely: if I'd asked people what they wanted, they would have said faster horses. And he's right, because other people didn't have the vision that Henry Ford had. Now, this is one of my favorite photographs on the right. And this was taken by Matthew Brady during the Civil War, and he was one of the early pioneers of wartime photography. And he's got some amazing pictures. I'm sure you've all seen the picture of Lincoln and the Civil War battlefields, et cetera. And he's the one that took all these pictures. But I thought this picture was particularly pertinent because this is something to me that demonstrates the power of vision. And you see, I say on the left, use vision, don't be constrained by what is the current state of something. And Jessica knows that I'm never satisfied by the status quo. If somebody is defending the status quo, they will be wrong. It's only a matter of when they'll be wrong, but they will inevitably be wrong. So be careful about defending the status quo. Now, if you look at these guys that are gathered around, here you have the radiologist on the far right. He's kind of looking off into the distance, thinking great thoughts. You have the anesthesiologist that's holding the patient's head, and you have the surgeon and the medical student here that's smoking a cigar. This is a typical modern OR, right? But if you would ask this surgeon that's about to saw this guy's leg off, if you would say, that's barbaric, that's crazy, the surgeon would say, what are you talking about? This is state of the art, man. This is like, I've got this brand new saw that the blades can be replaced when this thing gets dull. And I've got, all my buddies around to assist me. We have modern anesthesia. I mean, this is incredible. And the only innovation this guy could think of is if you gave him a sharper saw, right? But now think about this from our perspective, 150 years later. This looks incredibly barbaric. And just know that the current state today, in 20, 40, 50 years from now, is going to look like this. This is what you're going to look like. When they show pictures of you doing your job, the people are going to have the same reaction to what you're having when they're looking at this picture, okay? Because what's the state of the art today and what the status quo is today is not what the status quo is going to be tomorrow. And it's your job as a physician, an inventor, an academic, an entrepreneur to know what the future is going to look like, and that takes vision, okay? Okay, so you have this idea, you've had this vision about what the future can look like. Now, if there's any way that you can build a prototype, that will increase the value of your invention so much. It will make it so much easier to raise money and to demonstrate it and to communicate the idea. And it can be really ugly. That's no problem. Just try to make it so that it can barely function. And I'm going to embarrass myself here. And I'm going to show you the 4 prototypes of the 4 medical devices that I was involved in the development of that are now in clinical use. And this is going to be really embarrassing. Okay, so here's the first one. This is the Medtronic switching controller. And you can see on the left, that was our prototype. It was really, really ugly, but it kind of worked. It didn't work great. And then you can see the commercial system on the right. This is the NeuWave prototype on the left. And we used a commercial microwave power source and off-the-shelf devices, and we hand tune these antennas. It was ridiculous. It looked so bad. And you can see the commercial device on the right that has like 70% market share right now. This one's really embarrassing. This is Elucent Medical, and this is primarily for breast surgery, but it's being used for other applications now. And you can see this is my hand. If you look at the upper left-hand corner, that's my hand holding my original conception of what this thing would look like. And sure enough, that's green and red Play-Doh I used to build the first prototype. So as I said, these things can be really ugly. The first functioning prototypes were on the left. and the commercial system is now on the right, and we're taking huge market share with this device also. So from very ugly beginnings, that was 2015 when I made the first prototype, to market dominance. It really doesn't take that long if you have people with vision. And here's Histosonics. This is the Edison system, and you can see the first prototypes on the left. This is a very early ugly prototype, and you can see all those wires sticking out to this very sleek, futuristic looking robot on the right. So as ugly as it is, it doesn't even matter if it kind of works. If you can demonstrate your idea, that's just good enough. Once you've demoed your idea, now you have to protect it. And just because you have this great idea and you've been thinking big thoughts, you don't own it, and you can't go anywhere with just a random idea. You have to protect it first. In the US, they don't care whether you have a notebook in your closet that shows that you invented it on a certain day. You have to file it first with the patent office. And that can be costly. You have to think carefully about doing that, but it's pretty much that, and trade secrets are the only way to protect your ideas. And here you can see one of our patents for that Play-Doh device. You can see this is our original patent that we just was issued in 2021. Okay, so now you've invented your device, you've had some vision, you've built a prototype, you protected it, and now you have a huge decision point. This is going to be one of those lifetime decisions that you only have one shot to get right. And that is, do you license the technology? Do you give it to your university or your institution, who then will license it to a company if it's good? Or do you go the harder way, and that is to build your own company? And I've done this both ways. And there are pluses and minuses to doing it both. On the license side, it's fast, it's fairly easy. The institution will take the risk. So they'll put up the money for the patent, but they'll also take most of the reward, and you generally lose control of this. This is given to another company and you kind of lose control. The company side, if you decide to do this, it can be really hard. It can be really expensive, and it takes a long time. My first company, we started in 2008. We funded and sold it in 2016. And my other two companies, 2016 and 2018, started and haven't sold either of those. So it takes a long time, and this is really hard. I also had to mortgage my house to start the first company. And so, you know, this can be expensive, and you have to have a spouse that's willing to, or a partner that's willing to ride the ride with you, because this is a long, hard road. But if you're able to do it, it can be incredibly rewarding. And if you're a doctor founder, you can't do it yourself. Find especially engineers and people with business expertise, because building your team, a great team, is the best way to make sure that your company makes it. And I threw in this slide just team building 101 for physicians, because I've seen a lot of crash and burns from doctor companies and other doctor things. If you look at this thing on the right, it's called physician flight accidents. This is a report from 1966 that showed that doctors are inordinate risk takers in areas that are outside of their particular expertise. In other words, you have shall we say a surgeon? I'm just, of course, picking a random specialty. Let's say you have a surgeon, and they decide that they're going to become a pilot. Well, they tend, even in their current job as a surgeon, they may not take a whole lot of risks, but as a pilot, they take a lot of risks. And it turned out that in a couple of years, in 1965 and 1966, something like 65 doctors killed themselves in flight accidents because they overestimated their ability to be a pilot. So don't do that if you're going to have a business. Don't overestimate how smart you are. You know you're going to need technical and business expertise. You didn't learn any of that in medical school. So you got to go out and find that. Then lastly, you need to avoid being a jerk. Okay. And that's, it's maybe it may sound kind of trite, but it's absolutely true. And there's a number of reasons for that. And several of you have seen, I've given this example many times before, that if you are a jerk, your message and you can be mistaken. And the most tragic example of that I can think of is Semel Weiss, who was the chief resident at Vienna General Hospital in the 1840s. And one of his jobs was to chart maternal mortality. So he was an obstetrician. And he noticed a couple of things. First, that the mortality was very high. And second of all, that their two clinics had different mortality. And you can see the first clinic, which is in pink, had very high mortality. And this was run by medical students. And the nurse clinic in blue had much less mortality. And Semel Weiss was kind of an OCD sort of person, and he could not figure out why there was a difference in mortality in the two clinics until one day he put it all together. And that's when his best friend, who was a medical student, was in the cadaver lab and cut himself with a scalpel by accident and ended up dying from sepsis. And as his friend lay dying, Semel Weiss realized that the symptoms that his friend was demonstrating, the symptoms of sepsis, were exactly the same as the women that were dying after childbirth. And then he put it all together. He realized that the medical students in the first clinic were doing cadaver dissections with their bare hands without washing their hands, and then going to the clinic and delivering babies right afterwards. And he put it all together and realized that there was something, this was before germ theory, but realized there was something on their hands that was being transmitted to the women that were giving childbirth and killing the women. He instituted chlorine hand washing, and you can see what happened to maternal mortality. It dropped dramatically. And so Semel Weiss realized that he had made an incredible seminal discovery, and he knew that this could change the history of the world. And so Semel Weiss, though, as I mentioned, he was kind of an OCD sort of person. But what happened is he started going to medical meetings. And maybe this is what the AUR is like. I haven't been there in a couple of years, but Semel Weiss went to the meetings and started berating doctors about killing patients. And he made it really personal. And he got in people's face, you know, you're killing patients. And what happened is that he started to get written off as a madman. And people stopped listening to him because of his behavior and the fact that he was just such a jerk. And so that conflation of Semel Weiss's personality and his discoveries, that the fact that those were conflated together for 20-something years after his discovery of hand washing, there's millions of people died because people didn't listen to him because he was a jerk. So that's a really important reason when you're building a team as a physician, you are really good at your job and you're at the top of your field, but that doesn't mean that you know how to run a company and you know how to make a medical product. So be humble and listen to people with other skills around you as you build your team. This is the team that we built. Our first company we first named it Microblade, changed to NeuWave. We made all kinds of mistakes along the way. And if you're interested, I just cut 3 podcasts about the life of NeuWave from the beginning until the sale in 2016 on the Back Table Innovation podcast. And we tell all the stories of all the mistakes we made. And we made so many of them along the way, but somehow it ended up being a good story. Along the way, it's going to be important to raise money if you decide to end up making your own company. And this is really hard. There's several steps to this. As I mentioned before, I had to mortgage my house to make my first company, but I had also some friends and family that stepped up that helped us. Eventually, you'll need to go to venture capitalists, which are these guys. And I know all of you are fans of Shark Tank, and it's fun to watch. I've been on both sides of Shark Tank, both pitching companies and investing in companies, and it's incredibly interesting, and there's a ton of psychology involved with this. But I was fortunate in that my perennial investor is a guy named Scott Button from Venture Investors, who's incredibly fair and thoughtful and helpful for building companies. And if you get the right investor, they can really, really help you along the way. So this is a really big topic I'm not going to go into. Other than that, look for a great investor. The venture capitalist can help you find a great CEO. And again, I was incredibly fortunate to run into this lady, Laura King. And Laura, you'll know if you're in radiology, because Laura is the one person in the world who made the decision to go to digital mammography. And that is quite a mark on the world. She said she almost lost her job when she made that decision because people didn't believe that you could get enough resolution on conventional X-ray to make digital mammography work. And she ran the mammography business for GE Healthcare before leaving to actually join our company, NeuWave, and to run that. She left to run my next company, Elucent, and we brought in Dan Sullivan, who's an incredible CEO. He ran Superdimension before he ran NeuWave Medical, and he just exploded the company. He's got incredible commercial success, and he ended up being the person that helped sell our company to J&J Ethicon in 2016. Now, one thing you'll find out is that if you invent something, if you're an entrepreneur, if you're an inventor, you kind of catch the bug and you start looking at things through the lens of, geez, that was kind of fun and that was exciting. And, we were successful in doing that in one sphere. Can we do it again? And Laura and Dan and I, we were the founders of NeuWave Medical. We brought in Lee Wilkie, who's a breast surgeon, and founded Elucent Medical. And we funded that in 2015 and launched it right before the pandemic, which kind of stunk, as you can imagine, from our commercial uptake. But this is what the device is. It's actually a breast surgery device. And you can see a clip that is in a clear phantom. And the surgeon can then navigate to the clip and to the margins using the device, which is actually attached to the electrocautery system. So they don't even have to pick up another tool. You can use your Bovie as your navigator. And this is what it currently looks like in action. This is Lee doing a resection, and the device is telling her exactly where she is in relationship to the surgical margin throughout her surgery. So even though I'm a radiologist, this is an idea I had while I was dealing with all kinds of trouble with hook wires during my administrative life when I was our department vice chair. And that was enough to spark an idea in a big company. And now this company is trying to dominate this space also. Okay, so those are my planned remarks. In summary, invention and entrepreneurship, it does not conflict with your job. It is your responsibility as a physician, an academic, or as a private practice physician to develop the next set of medical tools. You should be doing that. There's lots of invention that's going on. It was catalyzed by the Buy Dole Act, as I mentioned before. There's no question that physicians invent the best medical devices. And if you're a company executive, you know this. And so they're always looking for things that we're inventing. And they're always sniffing around at what you're doing and will constantly be asking you your opinion about different devices. If you want to know where to start, just think about your own practice. What bugs you? What drives you crazy about your own practice? What's wrong with the status quo, knowing that the status quo will be proven wrong in the near future? If you can build a prototype, if you can show how it works, that will greatly increase the value and your chances of actually making it into patients. I told you about how to license a device versus starting your own company, and there are pluses and minuses to each one. Your own personal situation will help decide which one of those routes you want to go. If you decide to start a company, you're going to need to raise money. And this is a very long and very complicated topic, but basically you'll want to self-fund at the beginning. If you can bootstrap yourself to a working prototype, the value of your company will go a long ways. And one of the most important things is get the right CEO for the right time and then build your company like crazy. And if you want to know more about how that happened for us, the Backtable Innovation Podcast just dropped a 3-part podcast on our story. It's not the only way to bring things to patients, but it's the way that we did it. And it has a lot more detail than I was able to get in today. So with that, I thank you so much for your attention. Thank you so much for the invitation, Jess and Puneet. I really appreciate the opportunity to talk about some of our companies and our university and to brag about my buddy Jess, who keeps me out of trouble every single day in our department. And I'm happy to take questions or to listen to comments. Thank you so much.
Thanks so much. That was really fantastic, Dr. Lee. My 10-year-old is sitting with me, and I think is going to be a future entrepreneur, maybe even a radiologist after this. They were super engaged the whole time, so thank you. We have a few questions. Maybe I'll ask the first one and then we'll pass the baton. So the first question is from someone who is listed as AB. And the question is there a way to get from a first prototype of a device, for example, a new catheter, reduced to practice with third-party manufacturing, Is there a way to get that to 510K approval without having to source VC funds? And what would the outlines of that journey look like?
Oh boy. Yeah. So one of the things that we didn't talk about here is that medical devices are a regulated industry. And what I mean by that is, if you can imagine the MQSA pathway for what mammographers have to deal with on a daily basis, the medical device industry is like 5 times more regulated than that. And so your ability as an individual physician practitioner, even if you're deep into business and things like that, your ability to take something through 510K approval, which is the lowest bar for medical device approval, your chances of doing that successfully is very low. And I don't want to discourage you from trying, because I'm sure somebody probably has, but in this particular day and age, it is virtually impossible for a solo person to do that. And so you have a couple of different options about how you can do it. And I've seen everything from, again, form your own company, hire your own regulatory person, to outsource to consultants. A lot of times incubators will have a built-in regulatory person that can help advise you along the way. But it is, I don't want to discourage you, but it is a very daunting task for an individual. You are going to need help. You're going to need a really good regulatory person to walk you through it. Don't underestimate the amount of time, the amount of dollars and things you're going to need to make that happen. Just to kind of give you a frame of reference, for my first company, we had an inexperienced CEO estimated it was going to cost $600,000 to bring our device to approval. And Laura King, who I showed you just a minute ago, who's a very experienced CEO, she estimated it was going to take $5.5 million, and she was right on. That's what it took. And so it was a complicated device. It was more complicated than a catheter, et cetera, but the costs of this are really high, and the expertise is very specific. And so I would say you're going to need partnership in some way to be able to do it.
That's great. Thank you so much. This is a fascinating talk. We have another question from the audience. What made you choose between company versus license regarding particular inventions, belief in the product, encouragement from team members, or something else?
Oh, I tell this story in the podcasts, and maybe the best way to summarize it is a complete and total failure in my first attempt during licensing. And I have so many failures. I mean, that's like a whole podcast in itself. But I would say that the first experience I had with invention was when I was a resident back at the University of Rochester back in the dark ages. And I had an idea for a pulmonary artery catheter, not understanding that there was essentially no market for such a device. And so that was failure number one. That never really went anywhere. Failure number two was one of the first devices that I invented that is a commercial device, and you could still buy it on the market if you really wanted to, probably right now. I licensed that device to a large medical device company. There ended up being a dispute about the patent, and the company and the university, I didn't own the invention anymore. I gave it to our university, and the company and the university had a protracted fight about it that took a decade. And so based on that experience, I said to myself, if ever I invent anything else again, which I thought was very low probability, but if it ever happened again, then I was just going to do it myself. And it was mostly the reason was I had a bad experience. Now, I do know that there are many inventors have great experiences with licensing. I mean, Chuck Mistretta in our department, who invented digital subtraction angio, had a great experience with it, licensed his digital subtraction angio to virtually every large imaging company, a huge royalty stream, minimal hassle. He was allowed to invent with each of those other companies and improve the devices. So it was a wonderful experience. And so I don't want to tell you it's not the right thing to do. It wasn't for me because of my own failures probably, but it might be for you if you're not interested in, mortgaging your house and taking on a lot of risk and building a company which could take a decade or more. I would say that license is probably the way to go, and your institution, university will have a really well-defined pathway for that. I hope I'm not discouraging too many of you. This is, nothing in life is easy, and all of you are incredibly accomplished physicians, and you have so many accomplishments in your life, and you've done so much so well for so long. This is no different. All of us have jumped over hoops and jumped through hoops and jumped over fences and done what we were supposed to do, and this is no different. It's just a different area that we're not quite as familiar with as a traditional medical pathway. But just know that as a physician, you will be welcomed into the business world. You will have instant credibility. People will listen to you. They know that you have the best ideas. So don't be discouraged because you don't understand this world as well as anybody. I wasn't even an engineer. I was a history major in college, as Jessica knows, because I'm constantly talking about old stuff and being an old person and old outdated stuff. And I had no engineering background and somehow found myself, in this world mostly by accident. So if you're a physician, you're going to have great ideas. You're going to know what patients need. Don't hesitate. Nobody will laugh at you.
Well, I think you raised an interesting question. I think some of the audience probably is not from large institutions. I'm certainly not from a large institution, and I think that does create an added barrier for those who may want to invent and don't necessarily have those resources. So what advice would you have for people in that situation who may have great ideas, but clearly need some additional help? Where would they go to do that? Do they have to think about, particularly for our mid-career folks, do they have to think about moving institutions? Should they try to network with others who have walked this path before them? What is the best thing for them to do?
Well, first of all, Tara, don't talk down your institution. My daughter just rotated through there in emergency medicine and loved it. She said it was great. And I specifically asked her about radiology. She said it was excellent. So don't talk down your own institution. It's a great place. I happen to be fortunate in that the engineering school is just on the other side of campus, and I tell the story in the podcast that I walked over there and knocked on doors until I found an engineering professor that can help me. And no matter where you are, you're going to have to do a little bit of that. You're going to have to find somebody that can help you. If you're at a large university like mine, there's likely an engineering school, there's likely people around nearby. If you're not, though, there are all sorts of contract labs and I mean, seriously, just if you Googled engineering prototype development or something, you would find 100 companies that would come up that can help build your prototype and help get you to market. There are contract commercialization teams. I mean, you can find help anywhere if you just look for it. If you don't have built-in collaborators like I did, you'll probably have to give up a little bit more of your equity, and you might have to pay a little bit more up front for it. But there are plenty of great devices that came from, private practices, everywhere came up with all kinds of great stuff. So don't feel constrained by the size of your institution. If you have smart people around you, and I know all of you do, there's going to be people that can help you make this happen. You heard the story of Thomas Fogerty. I mean, he's 14 years old when he started coming up with some of these inventions, and they don't have to be complicated, incredible things. They can, if they just make somebody's life a little better, somebody's life a little easier, there's going to be a market for it.
I think there's a follow-up question, Fred. Any general thoughts on using third-party manufacturers for initial prototyping and any pitfalls?
Yeah, that's maybe that's a great follow-on question to what we were just talking about. Thanks for that, Puneet. I would say that most non-university based inventors do that exact thing. And what I would tell you is that if you are going to use a contract manufacturer, lab, commercialization, whatever you're going to do, if you think that your company has legs, try to pay for it with cash. Try not to give away large amounts of the company at the beginning, because you will come to regret that later if your company is successful. If your company is unsuccessful, then maybe it was a good thing to have given up equity, because it's worth zero. But if your company is successful, you'll find people that didn't contribute all that much to your invention and your company with ending up with a huge amount of the return. So especially at the beginning. So be really, really careful about giving away stock. You'll want to, when you go to a contract manufacturer, make sure that they built something that's related and something that is in your space. You don't want to have them inventing on the fly. You want to give them what it is and have them make it, and it should be something that they've already made or something related to it. And so just be careful, interview them carefully, try to pay cash. Hopefully they've made something that is somewhat related, so they don't have to do a lot of invention. You can get in trouble with contract manufacturers if they feel like they invented a lot of the product. You might find yourself in a situation where they could challenge you, and say like, they could file a patent or say that they invented a lot of it, and that can be trouble.
So I know how you function. And so I'm wondering if you could share a little bit with everyone else, kind of this marriage between career development and academic kind of acquisition of academic currency, in addition to the creativity, innovation that you have. And I'm wondering if you might spend a few minutes talking about the incredible mentor community that you've built with the students and the residents and the fellows that you have working in your labs, and how you've kind of combined mentoring, career development in younger people with your scientific endeavors and your innovations.
Oh, thanks, Jess. First of all, I have to say, I am incredibly fortunate to have kind of fallen into Wisconsin, because there's so many bright people around. And, I think when I look back at some of the companies that we formed and the successes we've had, I mean, it's mostly because of the people that have been around here in the community and things that have helped me and our companies along the way. Jess knows one of my recent students who recently left is Emily Knott, who is at Cleveland Clinic right now, who did an incredible amount of work on some of our inventions and things. Paul Lasky is one of my current partners. Meg Lubner, who is one of Jess and my partners, Louis Hinshaw, Tim Zemlevich. I mean, these people have used, they've used kind of our inventions and entrepreneurial stuff to build academic credentials. I mean, I think about Paul, when he was a MD PhD student in my lab, published over 30 papers. And Emily, who's again is now at Cleveland Clinic, she published 10 papers or something, or 12 papers during her time with me. And so the inventions and the entrepreneurship, as I mentioned before, it's not in conflict with your job. It can actually make your job better and help with academic success. Every university, when you come up for promotion, if you have patents, inventions, licensed things, if you have publications on your own inventions, all of that is incredible academic currency. And I would say that a patent really, that's something that's fairly rare, and that really raises the eyebrows of promotions committees and things. Jess, you're a guru about promotions and on promotions committees. Maybe you can comment on what you see come through and things that catch your eye when people come up for promotion with kind of invention sort of credentials. And Tara, you too, I know that you see a lot of these kind of packets come through in your job.
I mean, we see a lot of packets come through, but not a lot of packets that have patents in them, as you mentioned. But that is certainly a piece that really is, a very gigantic piece of gold bullion in the academic, in the promotion dossier.
I would think so, because, go ahead.
Well, I think even above and beyond that, it's, for our mid-career faculty, as they're looking to get into those next levels of leadership, the way they differentiate themselves is by having a unique profile and doing something that others haven't, especially when they are looking for NIH-funded researchers for chair positions or for section chief positions. I think it really only helps to make them distinct from other candidates. They really are the Waldos.
Absolutely. I know that I mentioned Emily Knott before, and I'll mention her again because hopefully she's going to be a radiologist someday. But when she was applying to medical school at Cleveland Clinic, which many of you know is a very research-based, small medical school class, I think there's 35 students per year, and there's no tuition there either. It's a 5-year program that's funded by the school. I got a call from the Dean of Admissions about Emily, and one of the things that she talked about was that really stood out about her application was the fact that she was on a patent. And in fact, the patent issued last week. And so, I think it's just something that's so different, and it proves creativity. And because patents cost money, somebody put money behind getting your invention out into the public sphere because it's likely to be useful sometime in the future. And it's how do you prove? I mean, that's like just proof on itself that you are a creative person that's changing the course of medicine. So I think pursuing a patent if you can, and many when I go to a meeting and I watch what people are presenting, I'm thinking to myself, man, you should patent that, and some people are talking about an algorithm or an AI thing or a way of looking at images or texture analysis or just, all these things I'm thinking to myself are patentable, and we don't know that enough amongst our community, I think, and we lose a lot of opportunities. But you can believe that the industry leaders are sitting in the back of the room and they're taking notes because they're going to use your idea to fund their businesses in the future. So think about patenting some of these incredible ideas that I see at every single meeting that I go to.
Can you give the audience a rough idea of how much a patent would run? I know there's different pricing for just a US only versus an international patent, right? Can you give the audience an idea of what the difference is and how much they roughly run?
Yeah, there's kind of 3 tiers of patents. The first is called a provisional patent. And what happens with a provisional patent, that's never even examined by the patent office. It's just a placeholder that says, I have an idea on this day, and here's roughly what it is. And so it preserves the date. And so you just have to write a rough description of what you're doing and send it in, and it's like, a couple $100. And that saves your date. From the day that it arrives in the patent office, you have 1 year to file a real patent, a utility patent. And those patents are the ones that are examined by the patent office, and they cost, depends, your law firm and all that stuff, but you should think about the order of $5,000 to $10,000 to do that. And then the third tier is, as you say, Tara, the international type patents, and the cost of those is unlimited. And I wouldn't spend a lot of time filing international patents because sometimes you have to do them in individual countries, and there's a charge for each country, and it can run up really fast. And that's basically the job of either the licensing company or your own company, and that's part of your fundraising, is to make sure that you have international patent coverage. If you're covered in the United States, it's the largest medical device market in the world. You have a lot of value. And so don't worry about filing worldwide. But a good patent attorney, $5,000 to $10,000 is what you should think about. Yeah, it's not cheap. It's not incredible, but it's not cheap.
So Fred, maybe we're running out of time, but I wanted to ask one question. Well, first, I want to say what an incredible speaker you are and how engaging you have been, and what a masterclass you have provided on this topic, and certainly decades of experience behind it, and how you're, marrying your entrepreneurship endeavors with, mentoring a pipeline of radiologists and medical students. Like it's mind-boggling and very humbling to see like how little my own accomplishments pale in kind of what you have done in your career. I wanna ask you like just a little. So when you are, let's say, mid-career, right? That's the theme of why we're doing these talks, is when you're mid-career and you really feel like you need to pivot, right? I know you've been section chief. I've known you, run your hospital admin. When you want to pivot from being maybe more like a traditional academic to maybe doing something unique, how was it navigating the local politics and your own mindset, where you said at one point, you mortgage your own house? Like, walk us through that shift in mindset and maybe share what you can without going too personal?
Thanks. Well, I would say that, first of all of us got into medicine to make a difference, right? And each of you, I mean, so I know you, Puneet, and Jess, and Tara, I've watched your careers, and you each are making a difference in a different way. And all of us have our own path about how we make a difference. One of the things, though, that I think we shouldn't be afraid of is that how you make a difference might change in your life, and it might change suddenly, and it might change for a personal reason or a professional reason. Many of you, I always talk about my own father quite a bit. Many of you know who he is. Every time you read a prostate MRI and you talk about the transition zone or the peripheral zone, or if you use PSA or PSA density, he's the one that brought all that to the world. And he was a private practice radiologist, and his pivot was because he got cancer. He got prostate cancer and got angry at the poor state of the art and how little was known about it. And so his pivot was for that reason. I personally came into radiology. I was going to be a clinical radiologist, and after a couple of years of that, I decided to become an academic radiologist with no particular invention or no particular ideas in mind. Other than that, I knew that I wanted to be more laboratory based, and I did that for many, many years. And then, as Jessica knows, I pivoted into administration and leadership for a number of years, probably too many years, I would say. And then late in my career, I pivoted back to almost all academics, and I won't do administration anymore, and I do a little bit of clinical. I told you, Jess bails me out on a daily basis when there's something that I mess up. But you know, I guess as a mid-career faculty, now is the time for you to pivot. And you know, you're a master at clinical radiology and the things that you were trained to do. You probably if you did the exact same thing you're doing now, you'd probably get a little bit better at it over a course of time. But you know, opportunities don't come around that often. And if you have a burning passion to try something else, now is the time to do it. Your job pays you enough that you can either go part-time or still support yourself doing clinical work, and then, you know, start a company in your garage, or become, you know, becomes a leader like Jess and Tara and you, Puneet, or, you know, pivot into administration or something like that, and you can still make a decent living doing it. So we do have the floor of our clinical jobs that can hold us up, but don't be afraid. I mean, go for it. I mean, I was fortunate. I pivoted 3 or 4 times in my life, and somehow it, you know, stumbled upon things that worked out for the most part. But I would say just don't be afraid. Just because you know, you thought your life was going to be one way, look at opportunities and look at some of those incredible people that you meet, and these really bizarre little occurrences that happen, and they can completely change your life. So I would just say, don't be afraid, and go for it if you have a passion for it.
Well, that was
Thanks
really
for
inspiring.
ending on that. Thanks for ending on the ripple effect. That was awesome.
Incredibly inspiring.
Thank you.
Unfortunately, I think I'm going to have to draw this session to a close. This has been fantastic. We've had a lot of engagement from our audience. This was really fascinating, and hopefully we can continue some of these discussions offline the next time we see you at one of the annual meetings. Would be wonderful.
Great. Thank you so much for your attention, everybody. It's great to meet you, and keep inspiring out there, okay?
Thank you so much.